Okay, good evening, class 9, unit light, part 3. Question number 1. Write some practical applications or advantages of the following: X-rays and ultraviolet rays. Solution: A. Practical applications of X-rays are as follows. X-ray. Number 1. To study heart tissues and bones, and to study the molecular structure of crystals. Number 1. Number 2, to cure cancer, and to sterilize some. In dairy industries also, X-ray is very useful in to kill bacteria, in dairy industry. X-ray is very important. B. Practical applications of ultraviolet rays are as follows. Number 1. To form the ozone layer. Ozone is very important because in stratosphere ozone is found. How? Oxygen is broken into, in the presence of ultraviolet rays, oxygen is broken into two oxygen atoms, O plus O. This oxygen atom combines with oxygen molecule in the presence of ultraviolet rays to form ozone, O3. Ozone protects us from harmful solar radiations. Number 2, to control pests or insects, to ensure purity of gems like diamond, etc. IV, to produce vitamin D, especially in the morning sunlight. Vitamin D is very important to our health. 5. To produce the visible light in fluorescent lamps, also called tube lights, fluorescent lamp. This ultraviolet ray is very important. Now, another question number 1 AB finished. Question number 2, and going to solve some questions, but before this, question number 2, distinguish between a number, light and sound wave, light wave and sound wave. Number A, number B, X-ray and ultraviolet rays. 2. X-ray and ultraviolet rays. See, number A is light and sound. Since it is related, light wave and sound wave are related. Number 1, what is the main difference of light wave and it is a transverse electromagnetic wave. Transverse electromagnetic wave. It is a just like transverse longitudinal mechanical wave. Just by the word transverse electromagnetic wave, light can travel through solid, liquid, gas, and even through vacuum. Sound, it is a longitudinal. It travels in the forms of compression and rarefaction. Mechanical wave means it needs a material medium to travel. It affects light, it affects eyes, it affects ears, it produces the sensation of It affects eyes means it produces the sensation of vision. It affects ears means it produces the sensation of hearing. And what about speed of light? Its speed in air or vacuum is 3 into 10 to the power 8 meter per second. Water 2.5 into 10 to the power 8 meter, 10 to the power 8 meter per second, and 2 into 10 to the power 8 meter per second in glass. And it has high speed, it has low speed. Another is number 3, its speed is 0 in vacuum, 3 lakh kilometer per second in light speed, 3 lakh kilometer per second in vacuum, but sound speed is 0 in vacuum and about 332 meter per second in air, about 1500 meter per second in water, and about 6000 meter per second in granite. See, sound speed is different. See, number 1, transverse electromagnetic wave, longitudinal mechanical wave. It produces the sensation of vision, it produces the sensation of hearing. Its speed is 3 into 10 to the power 8 meter per second in air or vacuum. In water it is about, not exactly, 2.5 into 10 to the power 8 meter per second in water, and 2 into 10 to the power 8 meter per second in glass. And it travels in the forms of crests and troughs. It travels in the forms of compression and rarefaction. Question number 2a. 2b, X-ray and ultraviolet ray. B number, X-ray and ultraviolet ray. Main differences. You can write the main differences between X-ray and ultraviolet ray. See, it is produced by an X-ray machine. X-ray machine. It is produced by the sun and an electric arc, just like tube light. Another, its wavelength is 10 to the power minus 11 meter to 10 to the power minus 7 meter. 10 to the power minus 11 or 10 to the power minus 7 meter. That means very small. See, very small, or minus 7 to minus 8 as well. 10 to the power ranging 10 to the power minus 11 meter to 10 to the power minus 8 meter. Its wavelength is 10 to the power minus 7 meter to 4 into 10 to the power 7 meter. That it shows that ultraviolet ray is bigger and X-ray is smaller. And another important is, what is the main use of X-ray? It is used to study heart tissue, and molecular structure. Molecular structure of crystal, kill cancer and bacteria. Kill bacteria in medical field, and its use. It is used to get vitamin D, or say vitamin D produce visible light in tube light. Tube light, also called mercury light or fluorescent lamp. So many others, and form the ozone. Main use, it is used or produced by the X-ray machine. It is produced by the sun and electric arc. How it is produced? Range of wavelength 10 to the power minus 11 meter to 10 to the power minus 8 meter. Wavelength ranges from 10 to the power minus 7 meter to 4 into 10 to the power minus 7 meter. Another use, the X-ray is used to study the heart tissue like bone, cartilage, molecular structure of crystal, kill cancer and bacteria in the dairy industry. Ultraviolet ray, it is used to get vitamin D, produce visible light in tube light and form the ozone. See, they are some of the main uses of X-ray, or main differences between X-ray and ultraviolet ray. Question number 1, use. Question number 2 is differences. And what about question number 3? Question number 3 is generally numerical problems. I am going to write down some numerical problems, but before this I am going to write down some state reasons, and next time numerical problems. See, state reasons. Number A, a coin or fish inside water seems to be raised. You have to explain. A coin or fish inside water seems to be raised. Here, water is the denser medium and air is the rarer medium. See, what happens? Water, it is bent away from the normal. See, what happens? The answer is a coin or fish inside water seems to be raised. Due to the refraction of light from water. Water means denser medium to air, rarer medium. It means when light passes from denser to a rarer medium, it is bent away from the normal. That means It due to the refraction of light from water to air. It means the refracted ray is bent away from the normal. A fish seems to be raised. In the same way, a glass rod or stick or pencil dipped obliquely, dipped obliquely is not straight inside water of a glass beaker seems to be bent. Why? A glass rod or a stick or pencil dipped obliquely inside water of a glass beaker seems to be bent. Same reason. A glass rod or pencil dipped obliquely inside water seems to be bent due to the refraction of light from water to air. Refraction of light from water to air. What happens? When light ray passes from water to air, it is bent away from the normal. So, any object coming from A seems to be coming from A dash. It means the object seems to be raised. And it is difficult to catch a fish inside water. You have to multiply by 1.33. The refractive index of water. Question number A, B, C. Written question. Question number C is, see, diamond sparkles more than glass. Diamond sparkles more than glass caught in a similar way. See, there are two pieces, one glass piece and another diamond piece. They look alike, caught in the similar way, but diamond sparkles more. What is the reason behind it? Critical angle. The critical angle of diamond is 24 degree, very small, but that of glass is 42 degree, means bigger or greater than 24 degree. 24 degree is very small, but 42 degree is very big in comparison to the diamond. So what happens? Just by 24, see, here 24, here 42, 24. Then what happens? Total internal reflection occurs. The critical angle of diamond is 24 degree, very small, but that of glass is 42 degree. So the total internal reflection occurs inside diamond. Inside diamond, total internal reflection, and multiple images are also called, not only total internal, multiple reflection inside, but that does not occur in glass. So diamond sparkles more than the glass cut in a similar way. D number. See, one is diamond sparkles. Both glass and diamond look alike, similar way, but glass has critical angle 42 degree, very high, but the critical angle of diamond is very small, 24. So total internal reflection occurs inside the diamond, due to which multiple images can be seen and it sparkles even at night. Another question is also there. See, is another question is stars twinkle. Stars twinkle. Why stars twinkle? You have to write down. See, actually stars twinkle. We say ताराहरू चम्किन्छ. Twinkle, चम्किनु. What is the reason? Different layers of air. See, actually air is a heterogeneous mixture. Different layers of air have different density, different densities. See, actually density is not a countable noun, but here to distinguish between density, I have written densities. Different layers of air have different densities which vary or differ in small ranges. Actually, air has the same density, but all density varies or differs to a very small amount. And what happens if the density varies? The convection current is produced. The convection current is produced and the relative positions of stars seem to change. The relative position of stars also seem to change. Then what happens? If the relative position change, what happens? This causes the twinkling of stars. In नेपाली हावाको विभिन्न ठाउँमा डेन्सिटी फरक हुन्छ. त्यो डेन्सिटी चाहिँ स्मल रेन्जमा फरक हुन्छ. त्यसमा कन्भेक्सन करेन्ट उत्पन्न हुन्छ. जुन कन्भेक्सन करेन्ट उत्पन्न भएपछि के हुन्छ त, रिलेटिभ पोजिसन अफ स्टार्स, यहाँको स्टार यतापट्टि आइरहेको जस्तो लाग्छ, कहिले यतापट्टि आइरहेको जस्तो लाग्छ. स्टार्स, सी, different layers of air have different densities. The densities slightly vary or differ from each other. There is convection current. Due to friction, the convection current is produced, and due to the production of the convection current, what happens? Actually stars don't change their position, but when we observe stars from the earth, we see that all the stars seem to change the position. If you walk, if you run, we think that stars are also moving, but actually stars don't move. They remain in their own position, but they seem to move. In this way, due to the relative position change, relative position of stars seem to change. Therefore, stars twinkle. Okay, this was for today.